All right, so today in lesson 51, we are focusing first on multiplying two-digit numbers. So if you see something like this, okay, right now, all we have done up to this point is multiply, for example, 43 times 20, like a multiple of 10, where you tack that 0 off on the end, okay? And so that is, yes, you have been multiplying double digits, sometimes more than that, but now that we don't have a 0 in the ones place, there is an algorithm that you must follow. And some of you already know it, some of you haven't learned it yet, so that's what we're going to go over today. Okay, so if I look at this very first example, I'm going to change my color really quick.
I know the answer. Okay.
All right, so I'm going to start in my ones place. I'm going to take pretend like I'm doing just 43 times 2. Okay, I'm only doing 43 times 2. So I'm going to use one color to, there we go. I'm going to use one color to represent the 2 here. So my 2 is going to multiply by the 3. What's 2 times 3?
6.
And what's 2 times 4? Okay, so that's no different than just multiplying 43 times 2. Where it changes is whenever I start multiplying the tens place, okay? I can't start 1 times 3 and put it here. Why? Because what place is this? This right here is this is the ones. I want to make sure I line it up in the tens place. So I would put once I'm done with this, mark it out and put a little placeholder here. Okay? Now I can start multiplying the number in the tens place. So 1 times, and it's just like normal. 1 times 3 is? 1 times 4 is? 4. Now what do you think I need to do to both of these? Paige. Add them. So these are called partial products. The 86 is a partial product. The 430 is a partial product. Okay? I'm going to show you something. We know that if we did 43 times 2, we would have 86. But if I did 43 times 10 in the old way that we used to do it, where we broke it up into tens and two, then it would be 430, okay? Which is my partial product. This matches this, and this matches this. Those are my partial products. But this method that we're looking at right here, this is the standard algorithm for multiplication. I just want you to understand why we're multiplying it the way we are, because it's still the same thing. You're multiplying it by a 1 digit, and then you're multiplying it by power of 10 at the next point. Okay, so we're going to add these together. And we have 6 plus nothing is 6. 8 plus 3 is 11. Carry the 1. This is just like normal addition. And then 1 plus 4 is 5. So my product of 43 times 12 is 516. Chase.
Number 13 is that same exact offer.
Oh, well, good. Lucky y'all. Y'all get a freebie today. All right. Yes. Okay. What about the red or green one that I gave you for Christmas?
I had it in my desk for Christmas, and then
Just use pencil and paper for now. Okay. All right. Not yet. Just 2-digit by 2-digit. All right, so let's do 57 times, okay, we'll do it in a minute then. Let's do 57 times 23. All right, so 7 times 3 is what? 21. I'm focusing just on this 3 first. So 21, and then 3 times 5 is 15, plus 2 is 17. Okay, so that's how I would normally multiply just 57 times 3. Now what I want to do is do 2 tens is how much? 20 essentially, right? So it's like I'm doing 57 times 20 because I'm going to hold my place value here in the ones. And now I'm going to start multiplying. 2 times 7 is 14. 2 times 5 is 10 plus the one that I carried, so 11. Okay, now I'll add these together. And my product is 1,311. So again, this is just like if I were to split it apart and do 57 times 3 and then add it to 57 times 20. Okay, you can do that, but you need to understand the standard algorithm as well. Okay, we are going to do a 3-digit by 2-digit number because it's in your written practice today. So let me erase this and I'll clear some space for a new one.
We could just skip it for tomorrow.
All right, so let's do 324 times 32. Okay, it looks big and scary, but it's not that bad. We're going to pretend like we're just doing 324 times 2 first. So we're going to take the 2 times 4, which is 8. Distribute the 2 times 2, which is 4.
Oh, but I know how to do that.
And then the 2 times the 3 is 6. Okay, so that's my first partial product. Now I'm moving over to the tens place. So I want to make sure I put a placeholder here in the ones. Now I'm going to do the same thing, but times 3. 3 times 4 is what? 12. And I carry my 1 up here. 3 times 2 plus the 1, 7. And then 3 times 3, 9. Okay, I add them together. And my answer is 10,368.
Whoa, that's a big number.
Is there anything wrong with pulling it apart and doing 324 times 2 and then doing 324 times 30? And doing it the way that you've learned to just by tucking that 0 away until the end. There's nothing wrong with it. It's just a little extra steps. Okay. What about if it's in a word problem? Do y'all want to do more like that? Just like a couple more plain ones? All right, let's look at this example. It says a restaurant chain purchased 95 pounds of potatoes for each of its 26 locations. About how many pounds of potatoes were purchased altogether? So what do we know?
It weighs more than my mom. Oh.
Well, I hope so. Yes. What else do we know though about this problem? We know that we're doing something all together. Does that necessarily mean adding?
No.
No, because look, I have other keywords like for each of its 26 locations. So a restaurant chain purchased 95 pounds of potatoes for each of its 26 locations. So that means I'm doing 95 times what? 26. Okay, so I'm going to start with the 6, and I'm going to do 95 times 6 first. So 6 times 5 is 30, carry the 3. And then 6 times 9 is, plus the 3 is 57. Okay, I'm done with that one. I like to mark it out sometimes so I know that I don't need to mess with it anymore. Done. Now I'm going to move over to the 2 in the tens place. I'm going to take 2 times 5, which is 10. Carry that 1. 2 times 9 is 18 plus the 1 is 18 plus 1 is 19. Okay, add this all together. And I end up with 2,470 what? 2,000 potatoes. Okay, now down here it says write the estimated amount of potatoes as a fractional part of a ton. It says 2,000 pounds is equal to 1 ton. So it's giving me like a little hint here. So that would be 1 ton. 1 and how much? 470th of 2,000. So 1 and 472 thousandths of a ton. Because the remainder, you know, you have to tack the remainder as the numerator. Okay, what about this one? At 35 cents each, what is the cost of 2 dozen pencils? What would I do?
Multiply 35 cents times 12. 24.
35 cents by 24, because it's 2 dozen. Okay, so the first thing I want to do is take my 4 and multiply it times the 5. So 4 times 5 is 20. And then 4 times 3
12.
plus the 2,
14.
14. And then the last part, 4 times 0
0.
plus the 1.
1.
Okay, so that's my first partial product. I'm done with the 4. And I hold my 1's place. Now I'm going to move over to the 10's place. I've got 2 10's. So 2 times 5 is 10. Hang on just a minute. 2 times 3 is 6 plus the 1 that I carried is 7. And then what is 2 times 0? Just 0. Okay. So I add it all up. And it's $8.40. Okay. Do we need to do any more of that?
No, now I actually did it.
Can you still, even with this one, if you're having side conversations, please stop. Can you still, with this one, break it up and do 35 cents times 4 and add this answer to 35 cents times 20? And then add them together. Yes, you can. It would work. So if I did that, this would end in a 0 here, and then 2 times 5 is 10. That's 7. Okay, so we're looking at, let's see, $7 here. And then if I do this, 12, 13, 14, looking at $1.40, and then I add them together and I get $8.40. Okay, so it would still work if you pulled it apart. Looking back at this right here is like my distributive property, where I'm taking piece, right. All right, distributive property. Benito wants to multiply 35 by 20 plus 4. Using the distributive property, show his 2 choices, then find each answer. So distributive property is when you take a number and you multiply it by each part. So what it's showing you is that you have 20 plus 4, so you could have 24 here. Or you could take 35 times 20, which is this, and then add it to 35 times 4, which is this. It's just a different way of looking at it. Okay, it's kind of like what I've been showing you with our standard algorithm, where you have like the 1 step versus breaking it apart into 2 steps. Okay, it's the same concept. You're still going to get the same answer. Okay. Now, if we look at this and we actually solve this out, are we going to get the same answer? Let's try it. Let's do 35 times, I'm not going to be able to see all that. Let's do 35 times 24, just like we've been doing. Okay, I'm going to take the 4 times 5, which is 20, and carry the 2. And then 4 times 3 is 12, plus 2 is 14. Okay, so there's my 1's place. Done with the 4, I'm going to hold the 1's place. Now I'm going to take 2 times 5, which is 10. And 2 times 3, which is 6, plus the 1 is 7. Okay, so if I add this together, I get 840. Now, is it going to be the same thing if I break it up like this?
Yes.
What do you think?
Yes.
Okay, so if I have 35 times 20, remember our rule when we've been multiplying by powers of 10, you just put that little 0 there. Then you multiply. 2 times 5 is 10, and that's 7. Okay, so I got 700. 35 times 4, just by multiplying 2 digit by 1 digit. Okay, I have these two together. If I add them together, I still get 840. Okay, just like our problem before, you can break it apart. Bryce, Please don't. You can break it apart and distribute. Okay, it just takes a little bit longer. Instead of doing it in one step, you're doing 2 multiplication problems and then adding them together. Okay, and you're still technically doing that. You're still technically doing that here. It's just all in one problem versus 2 separate problems. Does that make sense? Okay, are y'all ready to practice, or do y'all need to do another one? Oops. Okay, written practice starts on page 356. I will be bringing your papers to you. You guys have almost exactly 30 minutes, maybe a few seconds less.